You are most welcome to our SHUKLA Maths Academy online lecture series. Today in this video we will discuss about the normal form of a matrix. So now we start the process to understand the normal form of a matrix. So now there are mainly four normal forms of a matrix, and now any matrix can be reduced to any one of them. So there are four normal forms are these. First one is the IR, where I is the unit matrix of order R, and second one is the IRO, means IR is the unit matrix of order R, and the second and rest of the column will be 0. So this is called IRO or 0. And now third one is the IR 0. IR is the unit matrix of order R, and below this IR all the rows may be 0, then it is called IRO. And now fourth and last one is the IR, and all the columns in the right hand side and all the rows below this unit matrix will be 0, then it is called IRO. So we have these mainly four normal forms, and any matrix can be reduced by using the elementary row and column operations, any one of them. And after that, after getting the normal form, we can easily find the rank of a matrix. So now we will take here examples of normal form. Our first normal form is IR, that is where I is the unit matrix of order R. So now example is this. Now see here, this is the unit matrix of 3 cross 3. So this can be written in the form of I3, because I3 is the normal form of this matrix in general. And by using this normal form I3, we can easily find the rank of this matrix. It is also 3, because and the rank of a matrix by using normal form we will find it will be equal to the order of the unit matrix in the normal form. So rank of this matrix will be 3. Similarly, the example number 2 of the normal form IRO0. Now see that IR is here unit matrix of 3 cross 3, and the last column is whole 0. So this is called IR0 matrix. IR means here R is the order of this matrix, that is 3 cross 3. So we will take here 3 I3 and I3O, and also rank of this matrix must be equal to 3. Similarly, the third one is IR, and below the element or below the row of this IR matrix will be 0. So example of this normal form is 1 0 0 0 1 0 and 0 0 1 is the unit matrix of 3 cross 3, and last row is 0. So we can write this matrix in this form I30, and also rank of this matrix is 3. And similarly in the last form, that is IR, all the column in the right hand side and below the all rows are 0. So it is IR 0 0 0 form. The example of this, the unit matrix in this matrix is I2, only this, and remaining all the elements are 0 in the columns and also in the rows. Clearly, this is the I2 matrix, second order unit matrix, and remaining all the columns in the right hand side and below the all rows are 0. So the normal form of this matrix is I2 0 0 and 0. So rank of this matrix by using normal form is 2. So that's the concept of normal form. And remember that reducing in normal form of any matrix, we will use the row and column both the operations, and at the last we get any one of these four forms, normal forms. Then also we can find the rank of the matrix by using normal form. Now I am taking here an example of the normal form. The problem is that we have to give a matrix and we have to find the normal form of this matrix. So now see that first mark the principal diagonal of this matrix, that is 1 to 7. The process is that we must reduce this matrix into the unit matrix, and remaining column or rows will be 0. Means the diagonal element must be 1 and remaining all elements will be 0. Then this matrix becomes in the form of unit matrix, and there is a process or method to making this form. Now see here, with help of the first element of the principal diagonal, we will make here 0 by using the row operations. Now see that we will use here R2 minus R1, writing in R2, and also make here 0 with help of this one. So R3 minus twice of R1, writing in R3. So our matrix A becomes in the form, first row is unchanged 1, 2, 3, 4 as it is, and 1 minus 1 it is 0, and 2 minus 2 is 0, and it is also 0 and 0. So this row will be 0, and 2 minus 2 it is 0, 6 minus 4 that is 2, 7 minus 6 that is 1, and 6 minus 8 that is 2. Now see that our first element becomes 1, and below the element of this first one element all are 0, and after that we will use the column operations and making here 0. So now use here column operation, that is C2 minus twice of C1, and remember that here we will make the zeros with help of this one. So C2 minus twice of C1, writing in C2, and C3 minus 3 of C1, writing in C3, and also C4 minus 4 of C1, writing in C4. So our matrix A becomes first column as it is 1 0. So our first column is 1 0 0, and here 2 minus 2 it is 0, and here 0 and 2 as it is, and 3 minus 3 it is 0 and 0, and 4 minus 4 it is 0, 0 minus 0, and 2 minus 0 is, that is 2. Now see that in the element first of this matrix is 1, and all the elements right side in the columns are 0, and below the elements also all in the rows are 0, and after that we will make this element as 1. So how we will make this 1? First we interchange the rows R2 and R3, and after that we divide this column by 2, then we get here 1. So by the operation interchanging R2 and R3 and dividing this C2 by 2, we get the matrix A equal to, that is first row is unchanged 1 0 0 and 0. And now interchanging this R2 and R3, we get here 0, and also here we get 2, and dividing this column by 2, then we get this 1, and here that is 0 and 1, it is 1 and 2, and last row is 0 0 0, and it is also 0. Now making two elements in the diagonals are 1 1, and now last row is also 0, so we will make here zeros by using the column operations. So here use the column operations by C3 minus C2, writing in C3, and C4 minus twice of C2, writing in C4. So our matrix A becomes, first column is as it is 0 1 0, and here 0 and 1 minus 1 is 0 and 0, and here 0 also, and 2 minus 2 is 0, and that is 0. Now see that here we will make the zeros with help of this one by using only column operations here, and before this we are making here 0 by row operations, right? So clearly this is our required normal form, that is A is equivalent to I2 and remaining columns and rows are 0. So by using this normal form, row of A means rank of A is 2. So that's the concept of normal form of a matrix, and every matrix can be reduced any one normal form of the out of 4 normal forms. So that's the concept of normal form.